we want to solve AY double prime plus BY prime plus CY equals 0. Okay? So we try out y equals e to the RT. Okay? If y equals e to the RT, we get y prime equals r e to the RT, and y double prime equals r squared e to the RT. Okay? So we plug that in, we plug y prime and y double prime in, we get a r squared e to the RT plus b r e to the RT plus c e to the RT equals 0. Right? So I had a r squared e to the RT plus b r e to the RT plus c e to the RT. Okay? And that equals 0. Now each of these has an e to the RT in it. I can factor the e to the RT out and I can cancel it from both sides. And that gives me a r squared plus br plus c equals 0. Okay, that's a quadratic equation. We call this the characteristic equation. Okay, so that's the characteristic equation for this differential equation. AR squared plus BR plus C equals 0. So that's an algebraic equation that helps us solve the differential equation. The roots of this we always know the roots of this by the quadratic formula. So the roots are r equals minus b plus or minus square root of b squared minus 4ac all over 2a. It's just the quadratic formula. We have a, b, and c as our coefficients, so we just get the regular quadratic formula, r equals minus b plus or minus root b squared minus 4ac all over 2a. Now, there are three possibilities for what you might get there. You could get two real distinct roots. That's what happens if b squared minus 4ac is positive. You could get one real root, right? If b squared minus 4ac equals 0, then the only root you get is minus b over 2a. Or you could get imaginary, or that is to say complex roots. If b squared minus 4ac is negative, then what's under the square root is negative, you get an imaginary part, and so your root is going to be a complex number. Okay? So these are three different cases. We have thus far, just now, we've dealt with the case b squared minus 4ac is positive. So both of the examples that we did, if you go back and check, both of them fall into the category b squared minus 4ac is positive. Okay? So in that case, we've said everything about how to solve the equation. If b squared minus 4ac is positive, then you get two different real numbers for your roots. So let's call the roots r1 and r2. Your general solution will be y equals c1 e to the r1t plus c2 e to the r2t. And then you solve for the constant c1 and c2. If you only get one root out, which means b squared minus 4ac equals 0, or if you get complex roots, which means b squared minus 4ac is negative, then we have not said yet what you do to get solutions. But if b squared minus 4ac is positive, so your quadratic formula yields two real distinct roots, then we've said how to solve this equation. So coming up, we'll talk about how to solve this in the other two cases.